GIS Fundamentals, Section 10, Topics in Raster Analysis. Raster analysis range from simple to complex, largely due to the early invention, simplicity, and flexibility of the raster data model. Rasters are based on two-dimensional arrays, data structures supported by many of the earliest programming languages. The raster row and column format is among the easiest to specify in computer code and is easily understood, thereby encouraging modification, experimentation, and the creation of new raster operations. Raster cells can store nominal, ordinal, or interval ratio data, so a wide range of variables may be represented. Complex constructs may be built from raster data, including networks of connected cells or groups of cells to form areas. Time-varying and wide area phenomena are often analyzed using raster data, particularly when remotely sensed inputs are available. Map algebra. Map algebra is the cell-by-cell combination of raster data layers. Raster layers may be combined through operations such as layer addition, subtraction, and multiplication. Map algebra entails operations applied to one or more raster data layers. Unary operations apply to one data layer. Binary operations apply to two data layers. And higher order operations may involve many data layers. When layer extents differ, most GIS software will either restrict the operation to an area where input layers overlap. A null or a missing data number is usually assigned to cells where input data are lacking. Incompatible raster cell sizes cause ambiguities when raster layers are combined. It is best to choose only the values from the cells with complete overlap, or to use the median number, the average cell number, or some weighted average. The analyst may resample the data into a compatible coordinate system using transformation and resampling methods. As with vector operations, raster operations may be categorized as local, neighborhood, or global. Local operations use only the data in a single cell to calculate an output value. Neighborhood operations use data from a set of cells, and global operations use all data from a raster data layer. A neighborhood may be defined by a fixed number of cells in a specific arrangement. This neighborhood has a uniform area and dimension for most of the raster, with some minor adjustments needed near the edges of the raster data layer. Local functions. There is a broad number of local functions, or operations, that can be conveniently placed in one of four classes: mathematical functions, Boolean or logical operations, reclassification, and multi-layer overlay. Mathematical functions. We may generate a new data layer by applying mathematical functions on a cell-by-cell basis to input layers. A broad array of mathematical functions may be used, limited only by the constraints of the raster data model. Logical operations. There are many local functions that apply logical, also known as Boolean operations, to raster data. A logical operation typically involves the comparison of a cell to a scalar value or set of values and outputs a true or a false value. True is often represented by an output value of 1 and false by an output value of 0. There are three basic logical operations: and, or, and not. The and or operations require two input layers. These layers serve as a basis for comparison and assignment. And requires both input values to be true for the assignment of a true output. Typically, any non-zero value is considered to be true and zeros false. Note that output values are typically restricted to 1 and 0, even though there may be a range of input values. The OR operation. This cell-by-cell comparison assigns true to the output if either of the corresponding input cells is true. Null values are assigned when either of the inputs is null. A NOT operation. This operation switches true for false and false for true. Note that null input assigns null output. Many systems provide an XOR operation, known as an exclusive OR. This is similar to an OR operation, except that true values are assigned to the output only when one or the other of the inputs is true, but not both of the inputs are true. This is a more restrictive case than the general OR, and may be used in instances when we wish to distinguish among origins for a true assignment. Logical operations may be provided that perform ordinal or equality comparisons, or that test if cell values are null. Ordinal comparisons include less than, greater than, less than or equal to, greater than or equal to, equal, and not equal. We often need to test for missing or unassigned values in a raster data layer. The operation has no standard name and may be variously called is missing, is null, or some other descriptive name. A 0 is assigned to the corresponding output cell if a non-null value is found, otherwise a 1 is assigned. Logical operators may be applied to interval ratio, ordinal, and categorical data, although ordinal comparisons should be carefully applied to categorical data. Reclassification. Raster reclassification assigns output values that depend on a specific set of input values. Assignment is most often defined by a table, ranges of values, or a conditional test. Raster reclassification by a table is based on matching input cell values to a reclassification table. The reclassification table specifies the mapping between input values and output values. Each input cell value is compared to entries for an in column in the table. When a match is found, the corresponding out value is assigned to the output raster layer. A reclassification over a range is also a simple way to apply automated reclassification rules. Equal interval, equal area, natural breaks, or other automated class creation methods can be used. Data can also be reclassified to select the input source based on a condition. These conditional functions have varying syntax, but typically require a condition that results in a true or false outcome. The value or source layer assigned for a true outcome is specified, as is the value or source layer assigned for a false outcome. An example of one conditional function may be output equals con for conditional, parentheses, test, out if true, out if false. Where con is the conditional function, test is the condition to be tested, out if true defines the value assigned if the condition tests true, and out if false defines the value assigned if the condition tests false. Note that the value that is output may be a scalar value. For example, the number 2, or the value output, may come from the corresponding location in a specified raster layer. Nested functions. Local functions may be nested in analysis. Functions are nested when a function is used as the argument of another function. For example, we may wish to take the natural logarithm of all the cells in a layer. The mathematical logarithm function is only defined for positive values. When inputs are negative, we need to either accept null values in the output data layer or process these input cells in a different manner. We could do this by applying the absolute value function, ABS, to create an intermediate output. We could then apply the ln function to this output for a final result. This could be described as the equations init output equals ABS input layer, final output equals ln init output. We could do the same thing by nesting the functions if allowed by the GIS software. Final output equals ln parentheses ABS parentheses input layer. Overlay. Raster overlay combines features from 2 or more data layers and is among the most useful of spatial functions. Raster overlay is often restricted to nominal data. The cell values do not typically represent continuous variables, such as temperature, but rather categorical variables, such as type or township name. Although raster overlay may be implemented so that it admits continuous numbers, this typically results in too many unique cell combinations to be of much value. If continuous data are used, they are often converted to categories first. Raster overlay involves the cell-by-cell comparison of values in 2 or more layers. Overlay functions in map algebra can be created through addition and multiplication functions. Union operations can be performed with layer addition, and clip operations through multiplication. The union of 2 raster data layers may be performed through addition. A clip template is created that defines a binary mask, a set of cells that mask out a portion of the input layer. Cells to be passed through to the output layer are set to the value 1. Cells to be clipped away are set to the value 0. The clip template or layer is then multiplied by the input raster, yielding an output raster. Cell-by-cell multiplication by 1 passes values through to the output layer. Multiplication by 0 discards values for the cell, resulting in a clipped raster to the area of interest. Neighborhood, zonal, distance, and global functions. Neighborhood operations are applied in many analyses across a broad range of topics, including the calculation of slope, aspect, and spatial correlation.